Lesson 55B goes right along with 55A with distinguishable permutations. So we're continuing our study of permutations. And when we start looking at permutations, if I said I had 3 items and I wanted to find out how many different ways can those 3 items be arranged, I would say 3 factorial, 3 times 2 times 1, 6. We've already done that multiple times. However, when we're talking about distinguishable permutations, distinguishable mean telling the difference between the two. Sometimes in permutation study, we have more than one of the same item. And so it's hard to tell the difference. The book used the word moo, and they said, well, how many different ways can you, or different words could you arrange from the letters M-O-O? Now, they went ahead and I labeled them as M, there's only one M, so I didn't need to subscript it, O with a subscript, 2 with a subscript. And I went ahead and wrote out each different ways that I could do this. So I'd say M-O1, O2, M-O2, O1. O1, M-O2, O2, M-O1. O1, O2, M, O2, O1, M. Now I took the time to read all those because that's all the different ways. That's all 6 different ways of arranging those 3 letters. Okay. The problem is when we take off the subscripts, I end up with moo, OMO, OMO, And it sounds like I'm speaking some kind of weird language here. But what I've done is I've rearranged these and I realized I can't tell the difference between O1 being first and O2 being first because an O is an O. So I end up with these 2 being the same. So I just wrote it once. These 2 are the same, wrote it once. These 2 are the same, wrote it once. How many distinguishable permutations are there? Well, there's only 3. Well, that's much less than the 6 I should have come up with. And if I had the letters A, B, C, which are distinguishable, I would have had 6 different ways of writing A, B, C. But because of the repetition of the O's, I take some out, and I don't have as many distinguishable permutations. I can't tell the difference between these 2 moos, or those 2 omos, or these 2 ooms. So I have to take those out. Now, there's got to be an easy way to do that. There are 2 letters in here that are the same, so I go ahead and write a 2 factorial, and I realize it's the n factorial over 2 factorial. So 3 factorial over 2 factorial, okay? And when I do that, I say 3 times 2 factorial over 2 factorial, I end up with only 3, and it does work mathematically. So let's see if we can apply that with an actual example. 55.3 says, Jojo has 10 marbles, and I didn't write out the whole word problem. You can look at 55.3, but she has 3 red, 3 blue, and 4 green. How many different ways can she arrange these that are distinguishable? Well, if I were to just stop and say 10 factorial, she has 10 unique marbles. Each one of them had a letter on them. Each one of them were a little different shade of a color, or they were all unique, and the swirl on the inside was different. And I say, well, how many different ways can those be arranged? Well, 10 factorial is 3,628,800 different ways that they could be arranged. However, I can't tell the difference between one of the reds and another red, or 3 of the blue, one of the blues and another blue, or one of the greens and another green. So what I have to do here is I have to realize that these are going to have the distinguishable amounts. I've got 3 reds, 3 blues, 4 greens. So I take my 10 factorial, put it over 3, 3, and 4 factorial. That came from this right here. This is not terribly difficult, and if you're understanding what we're doing, we're saying I would have 10 factorial, except that I have a group of 3, another group of 3, and a group of 4 that are not distinguishable. I can't tell the difference. So when I do so, I end up writing this out, 10 all the way down to 1, and then I wrote 3, 2, 1, 3, 2, 1, 4, 3, 2, 1. I started crossing out. 1's cross, 2's cross, 3's cross, 4's cross. 1 doesn't need to be there because it's just 1, no problem. 2 and 3 is 6, I can cross those. 8 divided by 2 is 4, 9 divided by 3 is 3, and I have canceled everything out of the bottom, so I say 10 times 3 times 4 times 7 times 5, and that's 4,200. So I went from 3 million and change to only 4,200 distinguishable permutations. Now, I know the book doesn't show this exercise, but what if I had 10 marbles, okay? And I looked at it and said, oh, I had 10 marbles. They're all one color. How many different ways can they be arranged? Well, I think you can figure that out. It should be just 1, right? Well, if I did this, I would say, well, I have 10 and they're all red. Well, okay, so I have 10 factorial. Guess what that does mathematically? Well, that makes it just 1, and that's what it is. There's only one way. If I have 10 marbles and they're all the same color, how can they be arranged so I can tell the difference? one way. And this distinguishable permutations allows you to just divide out of your normal permutation that you would have, like in this case 10, down to what would I have if I took all of the duplicates out. Because the duplicates, I can't tell the difference. And that gives me, on this case, 4,200, or my own example here, just 1.